In this lesson, we'll discuss the Pauli Exclusion principle. This is the first rule used to determine how electrons are distributed in multi-electron atoms. The Pauli Exclusion principle states that no two electrons may have the same four quantum numbers. Each electron must have a distinct set of numbers. This tells us that if two electrons have the same first three quantum numbers, that is n, l, and m subscript l, then they must have a different fourth quantum number, meaning an opposite spin. For example, let's look at the 3s orbital of a multi-electron atom. An electron in the 3s orbital will have the quantum numbers n equals 3, l equals 0, and m subscript l equals 0. We know that two electrons can share these three quantum numbers, which means two electrons can share this orbital. One electron will have an upward spin with m subscript s equal to positive 1/2, and one electron will have a downward spin with m subscript s equal to negative 1/2. Now that we know each orbital is able to hold a maximum of 2 electrons, we can use this to determine how many electrons each subshell can hold. A subshell is what we'll call each L, that is the S, P, and D subshells. So starting with the S subshell, we know that there is one orbital. This one orbital can hold 2 electrons, so the S subshell can hold a max of 2 electrons. The P subshell, on the other hand, contains 3 orbitals. Each of these orbitals can hold 2 electrons, giving us a total of 6 electrons that the P subshell can hold. Lastly, we have the D subshell. The D subshell has 5 orbitals, holding a max of 2 electrons each, giving us a total of 10 electrons.